Problem number 3 says, let's see, we have the digits 0, 3, 6, and 9, and we're told that they're used to create the smallest integer that is divisible by 2, 3, 4, 5, 6, 8, 9, 10, and 11. And they're asking what is that integer? So there's actually a couple different ways that I know of that you could do it. There may be more, but two ways that I can think of. So I'm going to give you a couple of hints. One hint would be to remember what a least common multiple is. Now you've probably worked with least common multiples when you've added or subtracted fractions, because you want the denominator to be the least common multiple. So like if you're adding 1/2 and 1/3, the least common multiple of 2 and 3 is 6. So if we make the denominator 6 in both cases, then we'll have 3/6 plus 2/6. Okay, and then we can add them because they're both in the same denominator, right? And the denominator here, this is the LCM of 2 and 3. Okay? In this case, we're trying to find the smallest integer that is divisible by all of these things. So we're actually trying to find the least common multiple of all of this stuff. So that would be one way to think of this problem, is to find the least common multiple of all of these numbers. The other way to approach it is to remember your divisibility rules. So if a number is divisible by 2, it ends in an even number. If it's divisible by 3, the digits add up to 3. If a number is divisible by 4, then you can look at the last 2 digits of the number, and if it's divisible by 4, then the whole thing is divisible by 4. If it's divisible by 5, it ends in a 5 or a 0, right? If it's divisible by 6, then it's divisible by 2 and 3. So actually, we don't really need to look at 6, because if it's divisible by 2 and it's divisible by 3, then it has to be divisible by 6. If it's divisible by 8, the last 3 digits of the number will be divisible by 8. If it's divisible by 9, then all of the digits will add up to something that's divisible by 9. If it's divisible by 10, it's going to end in 0, right? Now, it also it's divisible by 10 if it's divisible by 5 and 2. So this sort of narrows down our cases for, here we said it had to end in either 5 or 0, but now we know it has to end in 0, right? And divisibility by 11, that one's not quite as well known, but you can actually look at, let's say we take a number like, like 121. We can take the alternate digits, so I can take 1 and 2 and I add them up and I get 2. And then the middle digit is 2, and I can actually take 2 minus 2. So you add alternate digits and then subtract the 2 quantities that you get. And if it's equal to 0 or a multiple of 11, then it's divisible by 11. So I'm actually going to be posting, my next lesson that I'm going to post is going to be on divisibility rules, so that not only can you learn those divisibility rules, but also understand why. Because I find that when you understand what you're doing, you remember it better. So that would be another way to approach it. Since you're given the digits, you could say, you can use the divisibility rules to figure out where the digits should be placed. Okay? So that's my hint. So let's go ahead and solve this problem. And I'm going to solve it in both of these ways. So I'm actually going to erase this stuff here, because I'll work with the least common multiple first. Actually, I think I can get rid of this too, because That was just an example. So let's take a look at these numbers. I'm going to erase this. All right. So to find the least common multiple, we need to look at the factors of all these numbers. Now, some of these are prime. 2 is a prime, 3 is a prime, 5 is a prime, and 11 is a prime. Okay? And this is just 2 squared. So if you were to break that down to its prime factors, it would be 2 times 2. This is 2 times 3. So its prime factors are 2 and 3. 8 is 2 cubed, which is 2 times 2 times 2. 9 is 3 squared, or 3 times 3. And 10 is 2 times 5, right? So if we break that down into the prime factors, that'll help us out. So we want to find the least common multiple. Now, one common multiple would be if you multiply all these numbers together, you'll get a common multiple, but it won't be the least common multiple. So what we want to do is find the smallest number that is divisible by all of these things, okay? All these numbers. So let's take a look at it, because I think we can eliminate some of these numbers. Now the prime factors, we want to keep those. So we're going to have at least 1 2. We're going to have at least 1 3. We're going to have at least 1 5, and we're going to have at least 1 11. Okay? And then some of those primes are duplicated down here. Like, for example, it has to be not only divisible by 2, but it has to be divisible by 4, and it has to be divisible by 8. So really we need 3 factors of 2 in our final number. So I'm actually going to write 2 cubed. Okay? And it has to be divisible by 3, but it also has to be divisible by 3 squared. So we want 2 factors of 3 in our final number. And let's see what else. It has to be divisible by 5. And so there's another factor of 5 here, but it's only once. So it only has to be divisible by 5 once, okay? Because there's no 5 squareds anywhere, okay? So if it's divisible by 5 and it's divisible by 2, it will be divisible by 10. So we don't really have to worry about 10. And then 11, the only factor of 11 is 11, so we don't need another, we don't need an exponent on that. So we can actually compute that out. So 2 cubed is 8, and 3 squared is 9, and so we'll just write 5 times 11, I could just write that as 55, right? And I guess I could say that is equal to 72 times 55, and I could compute that out. And I'll get 0, carry the 1, 35, that's 36. And I'll get 360 again, because I'm just multiplying by 5 again. If I add that up, I'm going to get 0, 6, 9, 3. Okay? So we actually didn't really even need this information that the digits 0, 3, 6, and 9 were the digits that were used to create that number, because it just turns out that way. So there's our answer. So that's one way to get it. Let's look at the other way that I mentioned to figure this out, and that was to use the divisibility rules. So I'm going to actually create a little, make little boxes for each digit of this number, okay? Because we're using 0, 3, 6, and 9. So I'm going to make 4 little placeholders here. And I know, because it's divisible by 10, that this number has to be 0. Okay? And so that's easy. So now I've got only 3 digits left to place. And I also know I want it to be divisible by 4. So I can actually look at these last two numbers and figure out what the second number should be, because the last two numbers have to be divisible by 4. So that means that we either have 30 or 60 or 90 would be our options for the last two digits. So if I divide any of those by 4, this is not divisible by 4. So if I divide it by 2, I get 15, and 15 is not even, so I can't divide it by 2 again. And the same way with 90, half of it would be 45, and if I took half again, I wouldn't get a whole number anymore. So 60 is the only one that's divisible by 4. And so that'd be half of that is 30, and half again is 15. So that's definitely divisible by 4. So this has to be a 6. All right, we're getting closer. So now we've got to narrow down actually to two options. We can either have 3960 or 9360, right? So let's take a look at the divisibility by 11 here. Now we know if it's divisible by 11, then if we take the alternating digits, so in this case I'd get 3 plus 6 is 9, and 9 plus 0 is 9. If I subtract those two, I get 0. So I know this one is divisible by 11. Okay? If I do the same thing here, if I take 9 plus 6, I get 15. And if I subtract 3 plus 0, that's 3. But that just gives me 12, which is not divisible by 11. So this number here is not divisible by 11. So really, my only option is this number, 3960, which actually matches this. But the one thing too is that they don't tell you that each digit is used once or anything like that. They just tell you that they're using those digits. So it's probably a good idea to check to make sure we've got everything covered with 3960, even though that's our only option if we're only using each digit once. So let's write out those. We want this to be divisible by 2, 3, 4, 5, 6, 8, 9, 10, and 11, right? And it's definitely divisible by 11. We did that. It's divisible by 9, because if we take 9 plus 9, we get 18. So that's 3 plus 9 plus 6 is 18. So it's divisible by 9. It's divisible by 3. It's even, so that is true. It's divisible by 10. So that means it's also divisible by 5. It's divisible by 4 because we looked at the last two digits and made it, and it's divisible by 4. It's divisible by 2 and 3, so it has to be divisible by 6. So the only thing that we haven't checked is 8. So if we take 960, which is the last three numbers, if I can write that, 360, and divide that by 8, we're going to get 8, 16, 2, we're going to get 120. So that's definitely divisible by 8 as well. So we've satisfied all of our conditions. And our answer is 3960.